The greedy rule is completely local here. A spot is safe exactly when it is empty and both neighbors are also empty, treating missing neighbors as empty too. We need to decide whether at least n new flowers can be planted without ever putting flowers in adjacent plots. Solve LeetCode 605. Can place flowers. Example 1 ends with answer true. Example 2 ends with answer false. The important sizing limits are 1 lesser equal flower bed dot length lesser equal to asterisk 104. Flower bed I is 0 or 1, and there are no 2 adjacent flowers in flower bed. The greedy choice works because planting at the earliest safe gap can only block its immediate neighbors, which were already unusable for any other simultaneous planting. Look at one index at a time and check left plot, current plot, and right plot. So in practice, if all 3 relevant positions are empty, plant here. After planting, skip forward because neighbors can no longer be used, and this greedy choice never hurts a future placement. The worked example turns into a simple counting question once the local placement rule is clear. This example can place 1 new flowers, so comparing that with n equals 1 gives the result. So the walkthrough goes in order. First count how many safe gaps the scan actually uses, then stop early if the count already reaches n, and finally the answer is whether placed greater or equal n. For the deeper version, the important thing is not more code first. It is naming the invariant that makes every local move safe. The long version should pause on the invariant or the local rule that makes the solution reliable, not just on the final code. So in practice, name the rule that stays true while scanning, connect that rule to the pointer or state movement, and then the implementation feels natural. The code is a direct implementation of the local rule. Check neighbors, plant if safe, and count placements. In the code, focus on 2 checkpoints. Watch where the answer updates inside the loop, then notice which value is returned to finish the reasoning. Here is the full greedy solution. The strength comes from the safe local placement rule, not from any complicated data structure. In the code, focus on 2 checkpoints. Watch where the answer updates inside the loop, then notice which value is returned to finish the reasoning. This is linear time and constant space, and the reusable pattern is greedy on a local neighborhood constraint. We scan the flower bed once. So in practice, time complexity, O(n), extra space, O1, and the greedy rule is valid because every decision is purely local. For more LeetCode practice, follow and subscribe to the channel. This is AI and human collaboration.